feels like I'm doing an open mic night. I haven't brought my guitar with me, unfortunately, but cool, great. In fact, I might do that. I'll hold on to it and see how we go from there. Cool. Hello, everyone. This is going to be like a short, snappy talk with 5 other smaller talks in the inside as well. Things might get a little bit strange. Things might get a little bit meta as well. But to quickly introduce myself, my name is Christopher Hunt, or Chris Hunt. I run a little consultancy called Controlled Frenzy, and I do prototyping, interesting creative technology work with organizations as small as 2 artists in a bedroom, just figuring out what they're going to do with AI or some technology, to figuring out how we do Node-RED and MQTT at scale at places like Ford and the National Gallery, and big installations, small installations, front end, back ends. I basically do whatever technological things people will pay me for, and luckily I've been doing it for long enough now that people are confident that I can actually deliver things. But to kind of go back to this talk, kind of recent adventures in building 3D things on the web, a lot of my work recently has involved working with 3D models and scenes and 3D.js and WebGL and all these kind of cool, interesting new, I say they're not new technologies anymore, but they're becoming really, really increasingly relevant. So this talk is kind of like a compressed tasting menu of all the technologies and things you need to know and explore when you're doing things on the back end, in 3D on the web. And likewise, all the kind of AI tools and things that help power that us as well. So some quick notes on this session. It's not intended to be exhaustive or definitive in any way. This is the line I use a lot lately, is this could easily be a whole year at university just focusing on these topics and just building stuff. We've got about 20, 15 minutes, if that, to speed through as much of the top end stuff in there as well. And also I want to be clear as well that the demos I'm going to be showing aren't my own work. I'm not going to be taking credit for them as well, because I'll be doing a lot of work that is unfortunately NDA'd. So I was like, I can't show you all the cool stuff I'm doing, but you will eventually. So you will see. But I thought I'd kind of introduce you to what's going on here. So the menu, our tasting menu today, we're going to start with course 1 of a little course of WebGL and then understanding what a GPU is. Then we're going to do a quick run through on 3JS, A-frame, and fiber, like what these things are, what they are as a technical level, how we approach that as well. Then we're going to look at 3D models themselves with GLTF and Model Viewer, and then the ski goggle wearing elephant in the room for our last course to finish off, and why adopting 3D web technologies is going to be very, very important very, very quickly, which builds off nicely of our last source telling you why you should be using AI right now in your things. This is kind of another thing on that slide as well. So thinking about the future, but we'll leave that to the end. So first up, 3D on the web. The key technology you probably hear about, the thing we go there is you hear about WebGL. And WebGL runs on the Canvas API, so that same tool we use to like draw things pixel by pixel on the web, and provides a OpenGL ES graphics API. So what that means is, how does the browser talk to the GPU? How's it telling our graphics processor how to do things and run things in 3D? And it's got support for shaders and rasterization and all this interesting stuff to make stuff, but it is very, very low level. It's pretty much every tool, everything you see on the web that's in 3D right now is running WebGL at the very, very bottom. So I thought I'd show this first demo of what example we can do with it. So this is a company called Crosswire. I can't vouch for their project, but their website is very, very cool. So notice as I scroll through the page, if I scroll with my scroll wheel, as I move through, there's a 3D scene behind the background, and the camera is moving through based on scroll. Again, this is all just HTML, Canvas, 3.js behind the scenes. And I can't vouch for how accessible it is as a website and how well it might work for mobility stuff. But clearly for their sorts of clients, for their sorts of people, they want people who are into like high-end technology, who want this like cutting-edge things. So they've obviously invested in this website with all these rich animations and transitions. And it's all just controlled through scrolling. And then as I get down towards the end, we see it's animating text in, it's sliding up interactives and call to actions and things. And all of that, behind the scenes, is preset animations, it's WebGL. So WebGL's a little bit old, but it's still very, very powerful. It can still do stuff like this. But the critical thing is WebGL is built on OpenGL ES 3.0. OpenGL is an old graphics library. So you might have heard of things like DirectX or Metal or Vulkan or even OpenGL. These are all tools game developers or people working in 3Ds use to talk to graphics processors, to kind of talk at a low level and figure out what they do, figure out how they build a thing. But as you can probably tell, it's very limited because the last update, the last reliable thing we rely on is based on APIs that came out in 2008. And it's now not 2008, it's significantly later than 2008. But luckily, the new technology now that is now coming in place is called WebGPU. And WebGPU, in a nutshell, allows our browser, Google Chrome in this case, to talk directly to the GPU on your computer. So now there's no kind of, like, it's more of an abstraction over modern APIs, and we won't get into the technical detail of that, but allows the browser much, much, much more control over what they can do. It allows us to run much more powerful things. So suddenly, games you make in Unity or Unreal or other platforms have the same graphics technology as they would as standalone applications as well. And this is already available. It's already launched in Chrome and it's coming to Safari and Firefox very, very soon. I wanted to show you an example of that working in action, this Popov demo. So I'm going to scratch that over. Brill. So this doesn't look as fancy as the last one, but to me, looking at this, I'm going, oh my God, this is really, really cool. This is really exciting. So this is doing C simulation with fast Fourier transforms, for those who want to get completely technical in it. But this is doing physics and light simulations kind of directly in the browser. So I can update the swell, I can update the wind speeds. And all of this interaction, this wasn't possible in the web before WebGPU, because this is high-level mathematics. This is 3D matrices. There's a lot of stuff going on to make this happen. But with WebGPU, that means we can package things up in a way that it just runs in the web browser. Someone can click on a link and get access to this. And it supports, like, if you're a video gamer, you've got a modern console, you've probably heard of things like ray tracing and direct GPU access. All of that stuff is now available to web developers in browsers to make really high-end, complex experiences. Cool. But it's not just graphics. It takes a little while to load this one, so I won't show it for this demo as well, but you can run AI simulations, because again, you've got access to the GPU directly to the browser. TensorFlow.js, as we were talking earlier, supports WebGPU now natively. So when you're running in Chrome, it's talking directly to your graphics processor to do those complex calculations and transitions all through that. So in this example, you can open up Chrome and you can run the full Stable Diffusion environment, full Stable Diffusion AI, generative AI, in your web browser. It'll take a few while to download the systems behind the scenes. It'll take a few up and RAM, but it's all running locally. It's not sending off a request to a server farm and coming back with something. It's all right there in your browser because WebGPU enables that kind of access and things into it as well. So it's opening up all sorts of exciting possibilities. So to conclude this first bit of the talk, WebGL is everywhere, and you can use it to do cool stuff, and it isn't going anywhere. That's an important thing to remember. So all this stuff that's built in WebGL will still continue to work well into the future. WebGPU, which is this new libraries, these new tools, is a bit experimental, is currently available in Chrome and opening up to all sorts of browsers, but it's opening the door to so many new things on the web. So you're probably thinking, okay, hang on, this is a little bit low level. I don't like talking about shaders and transforms and complex matrices and mathematics. I write HTML and JavaScript. What am I going to do about it? So let's go up a level and let's go to our next course and start thinking about other tools. 3JS, A-Frame, Fiber in this kind of example as well. So 3JS builds on top of WebGL/WebGPU now as well. And then it implements everything you need to build a 3D experience. So when you make something in WebGL, WebGL doesn't give you things like cameras and lightings, how to open up models, physics engines, all these things we'd associate with games and 3D experiences. That's where these libraries start coming in as well. You'll also see Babylon a lot as an example as well. That C example is built in Babylon. But 3JS is everywhere as well. And then if I go back out into our example, so this is 3.js running a 3D scene, so it's moving the camera automatically for us, it's loading some models and it's building some meshes for it. But for a code level, let's zoom in. Kind of looks like this. So if you've done ES6, if you've done JavaScript, this will start feeling familiar. But we have an init function, and we can see we're creating a camera and a scene and a background and a fog, and then we're loading objects and things. So this feels more familiar, right? This feels more like building things with JavaScript, more what we're used to as well. Cool. And 3.js is everywhere. So 3.js is one of those core bits of libraries on the internet that you kind of see pop up everywhere because it simplifies so much of what you need to make these 3D things that so many people have built stuff on top of 3.js. I'll say 3 a lot in this session as well. Don't turn it into a drinking game, whatever you do. So A-Frame builds on top of 3.js and then uses HTML markup to create 3D scenes. So we just had a look at how 3.js does it with JavaScript. Now with A-Frame, if I move over, so A-Frame, we have a very basic scene here. But if we go into the view the source, and then hopefully that will load. We'll wait for glitch to do its thing. Brilliant. So while that's loading in the background, A-Frame gives us somewhere to load objects, to create things, to generate lighting. And from a code level, brilliant. So let's get this index up. Brilliant. So can we all see that and see what's going on from a code level for A-Frame as well? So we've gone up another level. Instead of doing everything in JavaScript, what A-Frame allows us to do is once we've pulled in that JavaScript library, and we don't need to play around with NPM or any other complex stuff unless we need to, we can just write HTML code that looks like HTML. It's the same tags, the same things we're used to. So we have a scene for the scene and the environment, and then there's a box and a sphere, a cylinder, a plane, a sky, a color, text, media, video, objects. All of those become just things we can add in as well. So as a web developer, this is almost like our first step into making 3 stuff without, and we can still go into that 3D.js level, or we can go even down further into that WebGL level if we really want to. But A-Frame gives us that nice high-level starting point to go with as well. So if you're just starting and you're going, oh God, Chris, I don't know what to do, start with A-Frame, and we can build up from there. So I'll skip through the demo for this one as well. But for our React friends in the room, they're getting some nods and things, if we want to build something in 3D, we can use React 3 Fiber. And it looks very similar to what we just did with A-Frame, but just using React components and React's way of doing things. And that works really nicely with like Next.js or some of these other web developer tools as well. There's a great link to the sandbox here as well. We'll get all these links shared out for you to play around with and start exploring. But then there's libraries that build up, so you can then build 3D scenes using JSX, using things you're familiar with in React. So you don't necessarily need to go out and learn shaders and things. There's always a way into these 3D technologies using things you're comfortable with at a level you feel confident with as well. So like I said, to conclude, we don't need to go low level, and libraries like 3JS take out a lot of the complexity. It's very hard, it's very complex to make even a simple 3D game from a technological level. There's so many steps, but the tools we have today have built out so much possibility, so much availability, may as well start using them. So, moving on, maybe you don't want to build out a full scene. Maybe you just want to show some cool 3D models on the web page or something there as well. So we'll go through to talk number 3, GLTF and model viewer. So this is something you'll see everywhere. So GLTF or GLB, which is a different type of that file, but it's the same thing, is file formats for displaying 3D models. So the way I've listed it here is think of it like the JPEG. Think of it, you've got JPEGs for images, and we know JPEGs work everywhere. GLTF is like that, but for 3D models. And it's something you can kind of export to. So like you've got your Photoshop document and you export a compressed version of that image for the web as a JPEG or a WebP. You do the same with GLTF, and you can use Draco to compress files as well. So when we're being good developers, we compress all our media files. And then we can use tools like Model Viewer for displaying 3D models on the web. So Model Viewer is developed by Google, and it's using Google Search. It too is based on 3.js. And in Model Viewer, if I come out here, great. So in Model Viewer, again, that's our, oh, let's make that a bit bigger. If we look at the code again there as well, we've got a Model Viewer HTML tag, and then we're passing in the link to that file. And then suddenly, with that, we've got our 3D object loading into the page automatically with something we can click on and move around. If you're on a mobile phone, this also gives you a button to launch that object in augmented reality as well. So it gives us all this kind of ability just by dropping in a model and building stuff. So building on from Model Viewer, there is also a proposal for model. So the model HTML element or HTML tag, this has been proposed by Apple for obvious reasons, we'll get to them later, and is in the very early stages of the web. But what this will enable, should it be accepted, and I think it's very likely it will, is a way for every web browser to natively understand 3D models, to open that up automatically, interact with the rest of the operating system, and just provide you a simple tag to load something. So in this case, this is the proposal, is that you'll just have a model tag. Again, this looks very similar if we've done audio or video with multiple sources and things in there. So you have different sources for different operating systems, and then JavaScript libraries to interact with that model. Maybe you spin it around, maybe you interact with it as well. So all of this is kind of like developing and coming as well. So 3D things, 3D objects are going to very quickly become standard items in web browsers. And it may be that it becomes something we are expected to do as web developers. And kind of concluding that, it's easy to get 3D models into a web page as it is an image or video or sound. We can use Model Viewer today, and then eventually the model tag is going to come along and make our lives even easier. Now, kind of getting on to the elephant in the room, the last kind of stage is like, why? Okay, we're making all this 3D stuff in the web, like, why would people use it? Why people need this kind of thing as well? And I have to mention, does anyone in this room not know what this is? Got a hand? We've got 1 or 2 hands, right? And that's important. So this is Apple Vision Pro. This is Apple's augmented / virtual reality spatial computing headset, What's It? What's It's a technical term, obviously. And Apple have been working on this for years. This is similar to things like the Oculus Quest, where you are seeing the world through something and then you're being presented digital information layered on through cameras and stuff. And the key why I suggest you need to start paying attention to these 3D things is if any company was going to make wearing a headset with these goggles when we're at work, when we're at a desk with windows floating around us, it was going to be Apple. It was always going to be Apple. And it's been a long time coming getting to this point as well. And they've spent a lot of money and a lot of investment in Safari, in their web browsers, in their engines, to enable 3D things to happen in this space, in this spatial space, with web technologies. So we need to start paying attention very quickly, because if it's going to get popular, this is going to thing that's going to start it off. And what's great about that is they have a ton of easy to understand design guidelines. So I'd recommend this video, Meet Safari for Spatial Computing, and it will tell you all the things you probably need to adjust as a web developer to make your website work great. So that's things like having hover states when someone is like floating their finger up, or how you scroll, and how your CSS needs to work and be responsive and focus on vector graphics and all this good stuff. They go into some really detail, and they have really great code examples that you can just get and use and start adapting your website to as well. But we can start playing around with these tools now. So if I go into Xcode, so here we are. So this is the Apple Vision Pro simulator. This allows us to start opening up websites, opening up environments, and kind of seeing how things look when they are displayed in different places by people wearing the headset. So we can shift to the living room at night. And here is our A-frame scene we looked at before. But now we can press this VR button, allow. If you imagine you're in that headset, suddenly you can press a button and step into that web experience. You can suddenly interact with that and become more immersed in things. And this is all built around web standards, web technologies, WebXR, WebGL, WebGPU, all the stuff we're talking about, and it's powered by all these technologies we've been looking at today. And we can even, like we mentioned earlier, look at 3D objects. I've loaded a teacup here already. And you can just pull out 3D objects from web pages and put them on the desk in front of you. So if you're like browsing through IKEA and you go, oh, I want to see what that chair looks like, the user's going to be able to go to the IKEA website, press a button, pull out that chair and put it into the space around them, and it be accurately sized and spaced for that environment. And this isn't just hypothetical, this is all stuff that Apple have been building to and developing stuff, and developing all their technologies and platforms around. And a lot of this also works through Firefox and on the Oculus Quest, but the popularization of it is important as well. So if Apple can make a good case for these things, can transition, can make that cultural case for these technologies, then suddenly these are going to be everywhere. And as web developers, we're going to want to be able to embrace them. So, to conclude, if I go on the right slide. So, why 3D? Why this thing? As we mentioned, that kind of, if XR was going to happen, it's going to happen now. But adding 3D content today can be done for all sorts of devices, and while I've focused on XR that, as I mentioned earlier, anything you add today can adapt to different devices. So those 3D models you can see in AR on a mobile phone, or you can put them into a VR space, although all these interactions are available now and today. And it adds so much polish and features to our website, so it's not just about making 3D immersive experiences on the web, it's like all this technology is available to us to extend what we're doing today. And as we know, with WebGPU especially, browsers are incredibly powerful. You know, it's how far we've come in the last 15 years of how much the web is capable of, how much browsers are capable of, is incredible. And I want to encourage you to use it. Like we were talking with AI before in TensorFlow.js, and now here with 3D, there is so much capability there, so much things waiting to unlock with your creativity. And I'd love to see what you do with it. And that is everything from me. That was a very fast run through. Thank you for listening, and any questions?
I was going to say, about 6 months ago, I had this really random observation, which is that I hadn't realized that WebGL could be used as a background image.
Yes.
And it seems stupidly obvious now, but I just not noticed that for years and years and years. And so being able to do this stuff in the background of a page in a background process outside the main thread is just really powerful and cool. And I don't know, maybe everyone else knew that and I was just blind to it, but sometimes you just miss things hidden in plain sight. So it's pretty cool to see how this stuff has taken off so much.
Yes.
Cool. Any questions? Tom.
Hey, it was a great talk. Really enjoyed it. I've played around with 3JS before and made like primitives and
Yes.
circles and triangles and things. Really interested in what you showed about being able to load in models. Can you recommend any resources for a noob to go and make their own models? Is there like an MS Paint for 3D to make those GLT?
Great. So if you're a Windows user, Paint 3D. So in Windows, there is a 3D editor built into every Windows PC. Paint 3D is it as well, and it allows you to build and scale models. There is also, I think on iOS and Android, is an app called Polycam. And what Polycam allows you to do is do photogrammetry, so taking lots of photos and stitching it into a 3D module of objects. So you can open up the app and you can scan that beanbag right next to you. It will take thousands of images of that beanbag and kind of stitch them together with AI and then turn that into a model you can deploy on the web as well. So you don't necessarily need to be an expert 3D designer or know anything about Blender or something. The tools are available as well. On Apple, there's things like Apple Reality Composer as well, which is kind of building out these new tool sets and things for making models and experiences as well. And they're getting more and more accessible. So you don't need a master's in game engineering, game design to do any of this anymore. So cool. And SketchUp as well. SketchUp allows us to explore stuff, and there's Sketchfab as well for lots of commercial models that you can just download and buy and explore and play around with from there.